A good day to everyone who's watching. In our lesson today, we are going to talk about logarithms. Now, logarithms have a connection with the index numbers or the indices. Log of a number is the power of the base. Remember, the indices, we also said they are powers, they are exponents. So, a logarithm is an index. Now, the log has a base, the number that is equal to, that is the log of that number. Now, there is a connection between the indices and the logarithms. For example, remember in indices, we had 3 power 0 to give us 1. Yeah, so this is the index form. Now, in logarithmic form, log of 1 base 3, this one here is going to be 0. When I go to the next one, log of 3 base 3, this one is a 1. Log of 9 base 3, this one here is a 2. So here, log of a number is the power of the base, like I defined earlier. When you try to look at this one here, my power, the 0, is that one there, becomes now my log of the number, which is 1, and the base is 3. So the 3 in this case is going to be the base. This one is the answer, and then this is the number we talk about. Log of a number is the power of the base. Log of 1 is 0 to base 3. So this is the index form, and that one there is the logarithmic form. So you need to be knowing how to write such an index equation into a logarithmic equation, because when we are dealing with the equations, we are going to see how we do such a thing there. So we have our laws of logarithms there. The first one, if I have log of A base B plus log of C base B, this one here, writing it as a single logarithm, the other side is single logarithm. So I multiply what is there and keeping the base. Then if it is a minus, writing it as a single logarithm, I divide A divided by C, and then I keep the base. Then the third one there, a log of A power n base B. This one is going to be n log of A base B, the power somersaults and comes there. Then log of A base A is equal to 1. Lastly, log of 1 base B is equal to 0. Now, these laws there, they have some proofs, but we shall not go into that proof because this is O level. But I'm going to just talk about some of them. When you go to the fourth one here, remember when we had 3 power 1 is equal to the 3. So writing it in the index form, log of 3 base 3, that this one here is going to be a 1, just like that, right? If I have log of a number based the same number, that one, the whole thing is going to condense to a 1. Now, I also had 3 power 0, that this one is equal to 1. So in the index form, log of 1 base 3, this one here gives me a 0. So from here, this one is true, because any number power 0 is 1. So if I get log of 1 to any base, that one there is going to be a 0. So here, an example. If I have log of, let me say 27 power a half base 3, that this a half is going to somersault up to there. So this one is going to be a half. times log of 27 base what? Base 3. Then from there I can continue. Then here I can have my log of 3 base 10 minus log of 9 base 10. That this one here I need to write it as a single log. This is going to be log of 3 divided by 9 base 10, just like that. Then you continue with the simplification. Here an example, log of 8 plus log of 2 there. That one's going to be log of 8 times 2 there. So our example 1 there, evaluate the following. The part A there, log of 64 base 2. Now here we need to prime decompose the 64. Then we see what to do next. So prime decomposing 64, the 2 there, when I divide, that is 32. 32 divided by 2, that one there I get 16. 16 divided by 2, I get 8. 8 divided by 2, I get 4. 4 divided by 2, I get 2. 2 divided by 2, I get 1. So the 64 is the same as 2 power 1, 2, 3, 4, 5, 6. Like that. So my log of 64 base 2, this one here is equivalent to log of, now instead of writing 64, I'm replacing it with 2 power 6 base what? Base 2. Then now I use that law that makes this power to somersault there. So that's going to be 6 times log of 2 base 2 there. Then I use lastly the law that condenses this to a 1, log of a number base to the same number, that one's there becomes a 1, and when I multiply 6 times 1, I get the answer as 6. Part B there, log of 27 base 3. We're going to do the same thing, just to prime decompose the 27. Now, the evaluate, like I told you, they mean they want the final answer, the exact value. But to evaluate, you need to first of all simplify. That is why we're going to prime decompose. So prime decomposing 27 is the same as 3 cubed there. So when I substitute here, this is log of 3 power 3 base 3. Then that one is going to take that position, 3 log 3 base 3. Then the whole of this condenses to a 1. Then you have your answer as a 3. Now, as students normally don't know how to write the logarithm. They write log like this, log of 27 base 3. For them, they write it like log of, they write something like this. Others write log 327. Others write, they give this base and the number, they give them the same sizes. Please know the base should be a little bit smaller and a little bit down to the key, and then this one should be the size of those lines there that you have in the book. The part C there, we have 2 logarithms there. So what I'm going to do is to write them as a single log, that if I have an addition here of 2 logarithms, then on the next step, I write the multiplication of these ones here, log of 3.2 times 10, then base what? Base 2 there. Then now, I multiply here, so that becomes log of 32 base 2. when I multiply. Then prime decomposing 32, that becomes log 2 power 5 base 2 there. Then the 5 is going to somersault up to there. So that is 5 log of 2 base 2. And now this one is going to become 5 times 1, which is going to give me. Now, here, this one is a power, it's smaller, but when it somersaults, I rate it as a big whole number, right? The same size as the 2. But here previously it has been a power, just a power. Remember powers, we said rate them smaller than the bases. And then that is our part C. Our part D there, we can see some addition, then a subtraction there. So what we do is to combine them. We say if there is an addition, we multiply those figures there. Then this that has a minus, the log that has a minus, is going to divide. So I can combine it like that. Then get what is in the bracket there. So the 0 and cancel. The 2 gives me here a 20. 20 times that, I'm getting 100. Then 100 is the same as 10 squared base 10. The 2 is going to somersault here, so that is the 2. Log of 10 base 10. Log of 10 base 10 decomposes to a 1. 1 times 2, I get the answer as a 2. Now, there are some instances where they will just write log of 3 maybe plus log of 2, and then they tell you to simplify. Here you will not be seeing a base, right? So we take that one there, the base there to always be base 10. Where they give you the number and has no base, we take it to be base 10. Our part E there is a numerator and then a denominator. So the numerator prime decomposing, that one is automatically 2 squared base 2 divided by denominator, that is 2 power 3 base 2. Then this one here, numerator, the power is going to somersault. Also in the denominator, power is going to somersault up there. So this becomes 2 log 2 base 2 all over 3 log 2 base 2. So here we have 2 options. This part here is the same as that part, so they can just cancel out because they are both just multiplying in the numerator and the denominator, or taking this one to be a 1 and that one to be 1 to get our answer as 2 times 1 all over 3 times 1 to get it as 2 all over 3 there. So my example 2, if log of x is equal to p and log of y is equal to q, express in terms of p and q the following. Have part A there and then the part B there. So they want us to try to get rid of log of x to substitute there, p, then log of y to substitute there, q, in my parts here A and B. But you cannot easily substitute them if you don't have them as log of x and then log of y. So what we are going to do is that we are going to kind of dismantle again that expression. Remember, we have been compressing it, that is writing it as a single log, right? Using the laws there we first looked at. Now we are going to dismantle or take it back the way it was. The part A there, x squared is multiplying the y. So that one there is going to be equal to log of x squared plus log of y. So this is what I was talking about, taking it back, dismantling it, or writing it as distinct. Now I'm going to bring the power, because this log of x I want to substitute has nothing like a power. So I bring the 2 here. This is 2 log of x, then plus log of y there. Then now I can substitute. My log of x was given as a p, so this is going to be 2p plus log of y has been given as a q plus a q. So I've expressed this log in terms of p and q there. The part B, this is division, that is writing them as separate logarithms. This is going to be x log of x cubed, then minus log of y power a 4. Now I'm going to eliminate also the powers, because these ones here never had powers. That is, the powers they're going to somersault to become wholes, like that. Then now I'm going to substitute the whole of this, which was given as p. So this is 3p minus 4q. Example 3. If log of 2 is equal to 0.310 and log of 3 is equal to 0.4771, find without using tables or calculators part A, log of 6, and then part B there. So here, just like the previous example, we are going to write them as separate logarithm. That is, we are going to prime decompose now. 6 is a figure, and also part B, we are going to do the same, prime decompose the 72, and then we see how we come about with an independent log 2 and then log 3, then we substitute. Log 6, when you prime decompose, it gives me 2 power 1 times 3 power 1. Then I'm going to write this one here as separate logarithms. Then the power 1, and the number power 1 is the same number, so I can remove those powers. So this is log of 2 plus log of 3 using the laws of logarithm. This is a combination, then this is separate logarithm, keeping the base. The base, we say, if you don't see the base, just take it to be base 10. So this one here has been given the question as 0.3010, then plus 0.4771. Then from here, you can easily add the 2 using a carry, and then you write the answer. So why do they say without using tables or calculators? They want you to show them these steps here, the steps here, how you prime decompose 6, how 6 became 2 times 3. Then from 2 times 3 to become independent or separate logarithms. Then thereafter, you substitute what was given in the question. So my part B, 72, when I prime decompose, the lowest prime number there is a 2. So when I divide, I have 36. 36 divided by 2, there I have 18. 18 divided by 2, there I have a 9. 9 divided by 3, the next smallest prime number, I get a 3. Then 3 divided by 3, I get a 1. So my 72 is the same as 2 times 3, but the 2 appears 3 times and then the 3 appears twice. So this is what I'm going to substitute there. Log of 2 power 3 times 3 power 2. I write them as separate logarithm. Log of 2 power 3 plus log of 3 squared. So the powers somersault 3 log of 2, then plus 2 log of 3. Then I substitute that one. Was given in the question. 3 times 0.3010, then plus 2 times, I substitute this one, was given as 0.4771. Then you multiply, you get the answer. You multiply, you get the answer. Then you add, and you get the final answer there. Example 4, simplify the whole of that expression. So we are going to begin by, because our aim is to write the whole of this as a single log, so we're going to begin by taking back these values that are here. We take them back. Even that one, we take it back. So when there is nothing like there, then we can write it as a single log. So this one here is equivalent to log of 25 power half base 10 minus log of x power 2 base 10, then plus log of 2x squared base 10 there. Then if you can recall that we had the power a half to mean the square root. So square root of 25 is just the 5 base 10 minus x squared is just the x squared, then plus log of 2x squared base 10 there. Then now I'm going to combine them. Where there is a minus, this one is going to be dividing, and then this is a positive. So this, the value here is going to multiply the value there, then being divided by that one there. So this is log of 5 times 2 x squared, then divide by x squared, the base is 10. Then I simplify. X squared and x squared there, they cancel out. 5 times 2, that one is going to give me 10, base 10. Since they said simplify, we can leave the answer there. But if they said evaluate, we can go on and say that the answer is 1.